What's going on, first period pre-calculus? Once again, I'm back on video. Did not expect this to happen, but I'm looking outside right now and it is pretty white out there, so pumped we got a snow day. Here's the plan, because I think you might be watching this video first. Maybe you're watching Miss G's video, but we're gonna have 3 videos. Miss G's is gonna be about 15 minutes, and then I'm gonna make 2 videos that completes the notes for today. After you watch the notes, you can work on the homework assignment. We're gonna make sure that we post links to the textbook pages so that you are all set. Enjoy working at your own pace. If I'm talking too slow for you, you can toggle the speed and maybe watch me at 1.25 speed, but be careful because I listen to all my podcasts at 1.5 speed, and sometimes when my wife is talking to me, she's talking too slow. So I think I've really screwed myself up in that regard. So today's lesson is going to cover, it's going to be algebra heavy. So if you like algebra, you're in good shape. But these are all useful skills, and my goodness, are these huge in calculus. You got to know how to do this stuff. So it's all about functions. And functions freak people out when they first see them because they're all unsure of what the notation says. F of W, F of R, F of V. People get confused. So let's try to demystify functions here. The symbol, f of x, that's a symbol, is function notation for the value of f at x. So the f is almost like the y value. So and we'll talk about this in a second, but your x, that's your input. That's what you plug into the function, and then whatever it spits out is the y value, but instead of y, it's the f of x. It's the output. So inputs on the left, outputs on the right. In function notation, the x is the independent variable and the f of x is the dependent variable. And the independent variable is just a placeholder. Like this w right here, we could put anything into that function. This is saying f of w, but if we want to find f of -3, then what that means is that your input becomes -3. So it would literally be, instead of w cubed, it would be -3 cubed plus 3, instead of w squared, -3 squared minus 9. This, and I'll leave the f of w in the front, but I guess it wouldn't be f of w, it would be f of -3. So this is your new expression. You don't do anything with the front. That's just kind of your notation. What you do is you solve everything to the right side of the equal sign. So -3 times -3 is 9, times another -3 is -27. -3 squared is 9, 9 times 3 is 27, and then we have a minus 9. So that just ended up -27, 27 cancels out, and your final answer is -9. Okay, so that's what function notation represents. You take your inputs, you put them into the function. For sake of time, I'm going to do the second one and skip the third one because this one has a variable in it. So it says find f of -2. So I would literally make -2 my input. So 3 times, instead of r squared, it's -2 squared minus 3. What does that equal? -2 squared is 4. 4 times 3 is 12. 12 minus 3 is 9. So we got 9. But then look at this one. This tells you to find f of r plus 4. R plus 4 is your input. That becomes your x, your independent variable. So I'm going to literally take r plus 4 and put it into the variable slot. Let me show you what I mean. Instead of 3r squared minus 3, I'm going to replace this r with an r plus 4. So it would actually be 3r plus 4 squared minus 3. That is what I need to simplify. So then you're like, oh, Smith, that's a lot of algebra. Sure it is, but we need to get fast at doing this. R plus 4 squared, that's r plus 4 times r plus 4, remember? So that's r squared plus 4r plus 4r, 8r plus 16 minus 3. I want you to get faster at your multiplication and your expanding and your foiling, okay? Be confident in yourself. And then we need to clean this up. We get 3r squared plus 24r plus 16 times 3, 30 plus 18, 48 minus 3. Final answer, 3r squared plus 24r plus 45. You cannot simplify that anymore. That is your answer. Okay. So I'm not going to do this one because I'm trying to keep these videos under 15 minutes. But if g of b equals, and then they give you the expression, that's what matters. Because what you do is if they tell you to find g of x plus 5, you would take x plus 5 and you would put it into this slot and you would put it into this slot. And I actually think it will benefit you to see this written out. I'm not going to solve it out, but what I mean is you would solve for, if you're solving for g of x plus 5, it would be, so g of x plus 5 equals, instead of b squared, it's x plus 5 squared, and then instead of minus b, it's minus x plus 5, and then you have a minus 6. That is how it would look when it's expanded out. Obviously, you need to simplify that. Okay, so that's the notation. We need to know that when you say f of x, the x is the input, and you can put whatever you want into the function, and then whatever it spits out, that's your output. Okay, so that's skill number 1. Check. Skill number 2, solving the piecewise function. We did these with trig in the fall. Some of you loved them. It was kind of weird. Some of you loved these, and I've never had a student love a piecewise function, but you guys were sad these weren't on the quiz, which makes no sense to me. But that's a good thing because they're back. A piecewise function is a function that is defined by 2 or more equations, and the independent variable will determine which function to use. Okay, so what it means is if, for this example, is if I want to, so when x is, you have to look at these restrictions off to the side. When x is less than 5, then this is the function that we're operating under. Y equals x plus 6, right? A linear function. If x is greater than 5 or equal to, if your input is greater than or equal to 5, then you're operating under this linear function. Okay, that's what that means. So when it tells us to evaluate the following function when f of x equals 4, that is a typo. Because what they meant to say is not when it equals 4. We meant to say when f of 4. Okay, we need to find this. And so our input is 4. So we look over here, and which one do we use? Do we use this one? X is less than 1. No, we don't use that one because our input is 4. So we're going to use this one. So then we go down here and we plug in a 4. So f of 4 would be 4 cubed minus 4. So f of 4 is going to be equal to 4 cubed is 64 minus 4 is 60. Okay? And then we do the same thing over here. They want us to solve this piecewise f of 4. So we look, this is when x is less than 4, so we're not going to use that one. This is when x is bigger than 7, so we're not going to use that one. So this one includes 4, so we're going to use the middle one. So f of 4, we use the middle 2 times, instead of x squared, we put our 4 in, minus 3, and then you just reduce. And what is 4 squared? 16 times 2, 32 minus 3, 29. Okay? So piecewise functions are very similar to the first skill. It's just you have to pay attention to these. These right here, I'm putting the arrows on them. Those are your domain restrictions. And they tell you which function you should plug it into. Let me just, I think a lot of students get this mixed up, and it's actually very simple. But this would be function number 1, boxed in red, right? And this would be function number 2, boxed in green. Those are 2 separate pieces. If you were to graph this, and then I'm going to be done with this video, and we'll move into the next page, it would be x plus 6. So 1, 2, 3, 4, 5, 6. It will be something like that. But they only want you to keep it when x is less than 5. So 1, 2, 3, 4, 5. So it would be like right here. You would only keep that portion of the line. And then down here they say when x is less than x minus 4, so 1, 2, 3, 4. So that would be this, and they have the same slope, so it looks something like this. But this one is when x is greater than 5, so we go to 5, and we would only keep that much. So that would be what it would look like if we graphed it. So you get the idea. All right, if you feel unsure about skill 1 or 2, go back and you can rewatch this video. But I'm going to jump to the next video where we talk about determining the domain and range, which is huge, and then actually solving when a function equals 0 or when a function equals another function. Getting after it.